Hello my dear students, welcome back to the lecture series of methods of differentiation, and this is our lecture number 4. In this video we will discuss about the differentiation of inverse trigonometric functions, and this is part 2. In the previous class we discussed the differentiation of inverse trigonometric functions part 1, and here the inverse trigonometric function, differentiation of inverse trigonometric function part 2. So let's get into the video. So we continue with the previous class with question number 11. So y is equal to tan inverse of cos x by 1 plus x square, and the question was to find the derivative of this function, mean to find dy dx. And here you can differentiate this function by directly considering this total term inside tan inverse as x. Then by using the formula for differentiation of tan inverse x, you can find the result in that method also. As well, we have another method by simplifying this inner part of this function before differentiation, and finally we differentiate at the last part of the solution. So here tan inverse of, I am taking the second method actually. Here tan inverse of 1 plus sine x, this is actually cos x by 2 plus sine x by 2 whole square. You see here, because 1 plus sine x, 1 can be replaced by cos square x by 2, cos square x by 2 plus sine square x by 2, sine square x by 2, and then sine x can be written as 2 sine x by 2 into cos x by 2, and you see this one. Okay, you see here this 1 is equal to cos square x by 2 plus sine square x by 2, and then this sine x can be written as 2 sine x by 2 into cos x by 2, and you see this is of the form a square plus b square plus here plus sign 2ab, so it is a plus b whole square. So that is why I am writing 1 plus sine x as cos x by 2 plus sine x by 2 whole square. Okay, and in the numerator cos x, this can be considered as cos 2 into x by 2, mean cos twice x formula applying there, and cos twice x is equal to cos square x by 2 minus sine square x by 2. You know that one, cos twice x, you have the formula cos twice x is equal to, this is cos square x minus sine square x. This is the formula for cos twice x, but here we have cos x, mean half of twice x, therefore here also x by 2 x by 2. Okay, so I am using this formula here. Just wait 1 minute, I am erasing this. Okay, so this cos x is equal to cos square x by 2 minus sine square x by 2. Then tan inverse is remaining here. This is a square minus b square formula, and here a plus b whole square is there. A square minus b square formula will give us a plus b into a minus b. This is cos x by 2 plus sine x by 2 and cos x by 2 minus sine x by 2. This cos x by 2 plus sine x by 2 will cancel with this whole square, so it is simply this one, and the numerator will remain only cos x by 2 minus sine x by 2, and that is equal to tan inverse of dividing by cos x by 2 in the numerator and in the denominator. So it is 1 minus tan x by 2 divided by 1 plus tan x by 2. Actually my target is to make this inner function, this total inner function as a function of tan, so that I can cancel or I can remove this tan inverse. That is why my target is to make this total inner part in terms of tan function. Okay, so here 1 minus tan x by 2 divided by 1 plus tan x by 2 we discussed earlier in the previous video. It can be written like this, this tan inverse is remaining here. This 1 is actually 10 pi by 4 minus 10x by 2 is remaining same. Then it is 1 plus, here you may consider a 1 into 10x by 2 like that, and that 1 is equal to 10 pi by 4 into 10x by 2 is already here, and it is of the form 10a minus 10b divided by 1 plus 10a into 10b like that, and that is the formula for 10a plus b. So this tan inverse is remaining same, and this total part is equal to 10 a minus b formula, that is a is pi by 4 minus b is x by 2 here. So that this time this tan inverse and 10 can be removed, so we will have only pi by 4 minus x by 2. Now it is a simple term, and it is easy to differentiate this simple term now. So therefore y is equal to pi by 4 minus x by 2, and so dy dx is equal to pi by 4 is a constant number, so minus x by 2 derivative is 1 by 2 because x derivative is 1, by 2 is remaining same. Okay, so this is the result for the question, but you may also use that method also by considering this total term as x and applying the formula for differentiation of tan inverse function was 1 by 1 plus x square, this whole square, then into ddx of this part again you need. So you may apply that method also, but that method is something lengthy with respect to this method or compared to this method. Okay, so then you take another question, number 12, y is equal to cos of 2 sine inverse cos x. Again, since this function is sine inverse, so we make this cos function in terms of sine, so that this inverse and forward sine remove each other or eliminate each other. So we write like this, this cos x is actually equal to sine pi by 2 minus x, you know that one. So it is cos remaining same, 2 is remaining same, sine inverse, this cos x is equal to actually sine pi by 2 minus x. This is one trigonometric property, and then this sine and sine inverse will eliminate each other. So we have only cos of, this 2 is remaining same, and these two terms are eliminating each other, so pi by 2 minus x remaining. Completing this product, it is cos of pi minus 2x will be there, and it is equal to cos pi minus 2x, means cos pi minus theta form, and this is nothing but minus cos theta, so it is minus cos twice x is in the second quadrant actually, pi minus theta, cos pi minus theta, this is in the second quadrant, and in the second quadrant the cosine function is negative, and that is why it is minus cos twice x. Now it is y is equal to minus cos twice x. Now we can differentiate this. So dy dx is equal to, cos function derivative will be negative, so minus and that minus will make each other plus, and cos function derivative is sine twice x, and twice x derivative is 2, and I am writing 2 at a time here. It is of the form actually mx, cos mx. The formula is m sine mx, so it is m sine mx, and this minus and formula minus will make it positive term. So this is the result for the question. So we take another question, y is equal to tan inverse of this function. Now here you see this inner term, it is not possible to simplify this function in terms of tan, because here root over a minus b divided by a plus b, this is a constant term in front of tan, so there is no way to find this total term in terms of tan function. That is why here you have to use the direct formula of differentiation of tan inverse x. So here you see dy dx is equal to, it is, this is actually, this total term is considering as x. So tan inverse x function derivative is 1 by 1 plus x square. So it is 1 by 1 plus this whole term square will give us root over square is removing this, so it is a minus b divided by a plus b into, it was 10x by 2 and square is 10 square x by 2. Then we have to differentiate this inner part, this term considering as x, you are to differentiate that, and of that part this is a constant, so constant remaining same. Then differentiation of tan function is sec square it was x by 2, so sec square x by 2 into then differentiation of the inner part, x by 2 differentiation is simply 1 by 2 because x differentiation is 1 by 2 remaining same. Now just simplify it, we'll get the answer. So you see 1 by 1 plus a minus b by a plus b, it is already there, but tan square is actually sine square x by 2 divided by cos square x by 2, and here this root over is distributing here, sec square x by 2 is there, half is also already there. Then take LCM here, a plus b cos square x by 2 is the LCM, and that will go to the numerator. The LCM will go to the numerator. So it is equal to, the LCM is this one, and that is going to the numerator, a plus b cos square x by 2, and this term will multiply with 1, that is a plus b cos square x by 2 after taking LCM, then this plus is this one, and this term is remaining same, into all of the terms are remaining same here. Okay, so so this is the line, dy dx is equal to, this is the previous line, and here you see this a plus b, it can be considered as root over a plus b whole square. This one of the root over is cancelled, so it is a plus b into root a minus b is there. This cos square and cos square will cancel each other, and half is already remaining there. This is root over a plus b, this is root over a minus b, and here after completion of product, a cos square x by 2 and here a sin square x by 2, taking a common, so cos square x by 2 plus sin square x by 2, then plus here b cos square x by 2, and this is minus b sin square x by 2, so b is common, so it is cos square x by 2 minus sin square x by 2, and half is already there. And you can write this total term in a single radical sign like this, dy dx is equal to, it is root over a square minus b square, and this 2 is here, a into this is 1 because cos square theta plus sin square theta is 1, so a is there, then plus this is formula for cos 2 into x by 2, cos 2 theta actually, so cos 2 theta mean it is simply cos 2 into x by 2 is x only, and this is the solution for the question. So we take another question, number 14, y is equal to tan inverse of root over 1 plus sin x minus root over 1 minus sin x, and divided by root over 1 plus sin x plus root over 1 minus sin x, and here the condition given 0 up to pi by 2. And these conditions will be discussed in the chapter inverse trigonometric functions. Actually this question is also included in the chapter inverse trigonometric function, and there the question is asking like this, simplify, but here the question is to find the derivative of this function. So before finding the derivative of this function, first of all we simplify it, mean we should solve up to simplification of the chapter inverse trigonometric function. After that we just write 1 or 2 lines to get the differentiation of the function. And about these conditions we will discuss in that chapter inverse trigonometric function. Here we do not discuss about this. So here as in the previous case, 1 plus sin x, this is actually cos x by 2 plus sin x by 2 whole square, like that, and 1 minus sin x by 2, this is cos x by 2 minus sin x by 2 whole square, and similarly here also and here also. You write tan inverse is there into root over of, this is cos x by 2 plus sin x by 2 whole square minus this one, and for this it is same, and for this it is same. Then you already know this one, you see here, you already know root over of x square, it is equivalent to modulus of x, is not it? Root over of x square is equivalent to modulus of x, and here you see, root over of this term whole square, so it will be mod of this term, mod of this term, mod of this term, and mod of this term. You write that line. So tan inverse of these are. But you see here the value of x is given from 0 up to pi by 2. So x by 2 will from 0 up to pi by 4, is not it? So from 0 up to pi by 4, you think cos x by 2 value is always greater than sin x by 2 value. from 0 up to pi by 4, in that interval from 0 up to pi by 4, you see the values of cos function is greater than the values of sine function. And here cos x by 2, sin x by 2, both are positive numbers, so mod of positive number is positive itself. And here value of cos is greater than value of sine, that means this entire term is a positive term, and mod of positive term is itself. But if the inner part is a negative term, then you are to give a compulsory minus sign when you remove the modulus sign. You know that process by the definition of modulus sign. You see here, to balokor nishoy monor ase, moi olopman lekhai disu. Modulus of x function or jitu definition formula asile, sorry not formula, definition asile, it was x when x is greater than 0 and minus x when x is less than 0. বুজি পাইছে না? সো ইয়াটো সেই একেটাই কথা, যে এই টোটাল পার্টটো যদি পজিটিভ হয় তো মই ডাইরেক্ট মডুলাসটো রিমুভ কৰিব পাৰো, বাট এই ইনার পার্টটো যদি নেগেটিভ হয় তেতিয়াহলে মই এটা ফ্রন্টে দি মাইনাস লাগাব লাগিব। এন্ড কন্ডিশন অন x ইজ গিভেন হিয়ার। মই অলরেডি কৈছো যে ফ্রম 0 আপ টু পাই বাই 4, কারণ x/2 এঙ্গল মই কনসিডার কৰিব লাগিব, সো x/2 এঙ্গল ইজ ফ্রম 0 আপ টু pi by 4, and from 0 up to pi by 4 cos is a positive number, sine is also a positive number, so sum is positive, etu same thakibo. Yate cos is more than sine, moi already koisu je 0 pora pi by 4 leke jibilak values thakibo সেই values bilakor bhitorot cos or values bilak sine or value kori beshi thake, so this difference is a positive number, সেই কারণে etu as it is রই গল, this negative is already there, etu as it is রই গল। And cos x by 2 এটো তো সেম থাকিব, এজ ইট ইজ রয়ে যাব কারণ এটো পজিটিভ নাম্বার, এন্ড প্লাস ইয়াতো এটো সেম থাকিব কারণ cos x by 2 minus sin x by 2 এটো পজিটিভ টার্ম হ'ব। আচ্ছা তোমালোকে ইয়াতে অলপমান লক্ষ্য কৰিবা, মোৰ অলপ টাইপিং এৰর এটা হৈ গৈছে, এইটো সাইন এটো প্লাস হ'ব লাগিছিল, দিস সাইন ইজ টু প্লাস, ঠিক কৰি লিখিবা তোমালোকে, এটো প্লাস সাইন দিবা দেই, দিস ইজ প্লাস। সো নাও হিয়ার ইউ সি cos is cancelled, so it is 2 sin x by 2. Here sin cancel, 2 cos x by 2. So মোৰ টার্গেট কিন্তু একেটাই, এই ভিতৰত যিখিনি থাকিব এই ভিতৰৰ বস্তুখিনি মই 10 ফাংশনলৈকে লবলৈ ট্রাই কৰিম যাতে দিস এই 10 ইনভার্স আৰু 10 ফাংশনটো ৰিমুভ হৈ যায়। সো হিয়াৰ ইউ সি এটো তো প্রিভিয়াস লাইনটো থাকি গল বাৰু। So 10 inverse of this is 2 sin x by 2 and this is 2 cos x by 2, 2 cancel, and 10 x by 2, 10 inverse and 10 remove, so it is simply x by 2. Now y is equal to x by 2 only, y is equal to x by 2, so dy dx is half only. Okay, this is the solution of the problem, and this question is homework for you. Y is equal to sine of 2 10 inverse this one. So here you may solve this question in two ways, by directly considering this as x, or by taking this x is equal to cos 2 theta. We have a theory discussed in the previous class that root over of a power k minus x power k divided by a power k plus x power k, etu monot ase ne? This is, in this case you should take x power k is equal to a power k cos 2 theta, monot ase na kotha tu, cos 2 theta. This is the process. Okay, so here you see it is root over of a is 1 and k is also 1, 1 minus x 1 plus x, so you should take here x is equal to cos 2 theta. Okay, tumi yate x is equal to cos 2 theta lobo lagibo, yate x is equal to cos 2 theta loi loba, ekdom easily ahi jabo। তেতিয়াহলে ইয়াত আহিব numerator will be 1 minus cos 2 theta and this is 1 plus cos 2 theta, so 1 minus cos 2 theta is 2 sin square theta and 1 plus cos 2 theta is 2 cos square theta, so sin square by cos square is 10 square, root over will remove it, only 10 theta, inverse 10 will go, it is 2 theta, and then find the derivative of sin 2 theta only, that is the solution. Okay, so 2 theta, and finally you should also replace the value of theta also, after replacing the value of theta you find the differentiation. Okay, so I am erasing this. Just a minute. Okay. So the next question is y is equal to tan inverse 3x minus x cube divided by 1 minus 3x square. And here we have a special substitution. You can solve the problem by direct method by taking this total term as x. So dy dx is equal to 1 by 1 plus this whole square, then ddx of this term, and by simplifying that you can find the answer also. But I am not using that method here. I will simplify this function before differentiation. Okay, so here you see we have a special substitution of trigonometry, that if you see here that if you take x is equal to tan theta, then it is 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta, and that has a formula. You know that one. Tan 3 theta, this is equal to 3 tan theta. You have the formula in first year. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. 3 tan square theta. This is a formula, and that is why we are taking here x is equal to tan theta. So you see here, let x is equal to tan theta. So theta will be equal to simply tan inverse x. So using these substitutions here. So y is equal to tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. So it is tan inverse of tan 3 theta. So inverse and forward function will eliminate each other. So tan 3 theta, and before differentiation you replace the value of theta, and you see here theta is what? Theta is equal to tan inverse x. So use that value here. Theta is equal to tan inverse x. So it is y is equal to 3 tan inverse x, and now differentiate. dy dx is equal to 3 into tan inverse x function derivative is 1 by 1 plus x square, and that's is the solution for the question. Okay, so we take another question, number 17. It is cos inverse of 1 minus x square divided by 1 plus x square. Here also one special substitution. You think about x. If you take x is equal to tan theta again, then it is 1 minus tan square theta divided by 1 plus tan square theta, and that is a formula for cos 2 theta. You know that one. It is obtained in the first year class. So let x is equal to tan theta, then theta is equal to tan inverse x, as like the previous question. So y is equal to cos inverse of 1 minus tan square divided by 1 plus tan square is equal to cos inverse of cos 2 theta. This will eliminate each other, 2 theta, and so it is 2 into theta is tan inverse x. Now actually y is equal to 2 tan inverse x. But I want to tell you one thing, that we have a trigonometric formula that cos inverse of this is can be directly written as 2 tan inverse x. Cos inverse this term can be directly written as 2 tan inverse x. I will give you that formula here below this one, and before that I am writing the differentiation. So dy dx is equal to 2 is remaining here, and tan inverse x derivative is 1 by 1 plus x square, and that is the solution for the question. You see this one, 2 tan inverse x will be equal to tan inverse of 2x by 1 minus x square, and that is also is equal to sine inverse of 2x by 1 plus x square, and that is also is equal to cos inverse of 1 minus x square by 1 plus x square. And here I am using this term is equal to 2 tan inverse x. If you have some problems like this, sine inverse twice x by 1 plus x square, in that case also you can write 2 tan inverse x. Also if you have tan inverse 2x by 1 minus x square, then you can also write 2 tan inverse x. That is, there are actually 3 formula. This is equal to this one. You may use this equal to this, or you may use this equal to this. So here I am using this value is equal to 2 tan inverse x. So in your exam you may use direct value of this is equal to this, because this formula is given in your chapter inverse trigonometric function, very beginning of your book. So these theorems or formula will be discussed in details in that chapter, but for this chapter we are just using the formula. But how this is equal to 2 tan inverse x, how this is equal to 2 tan inverse x, this types of questions are arising in your mind, but we will discuss those in the chapter inverse trigonometric functions. So do not confuse now, just memorize this one for now only. Okay, so this is the solution for the question. That means you can write y is equal to, in place of this directly you can write this one, and after that you just write dy dx is equal to this one. Okay, so these types of question asked for 1 mark, 2 marks only. Okay, so this is another question, y is equal to x square sec inverse x minus root over this one. Simple. Here product rule will apply, and root over function derivative you already know. So dy dx is equal to x square, derivative is twice x, sec inverse remaining same, plus this x square remaining same, sec inverse function derivative formula is 1 by x into root over 1 minus x square minus 1. You know already this. Then this minus is here, and now root over function derivative is 1 by 2 root over x square minus 1 into this x square minus 1 function derivative is simply twice x. So this 2 and this 2 will cancelled out. Here x and x is cancelled out. So we have 2x sec inverse x plus here x by root over x square minus 1, and here also minus x by root over x square minus 1. So this term and this term will cancelled out. Only we have the answer is twice x sec inverse x, and that is the solution. Now this question is homework for you. You can solve yourself. Y is equal to x cos inverse 1 minus x square by 1 plus x square. Again you use that formula 2 tan inverse x here, because cos inverse 1 minus x square by 1 plus x square is equal to only 2 tan inverse x. So before differentiate this, first use that formula. So y is equal to x into this term is 2 tan inverse x, that is twice x tan inverse x. Now we will apply the product rule here. So dy dx is equal to this 2x derivative is 2 only, tan inverse x remaining same, then plus 2x remaining same, and tan inverse function derivative is 1 by 1 plus x square only. Okay, so now just simple calculation, 2 tan inverse x, this is twice x by this one. You may leave the answer here. Okay, this question is again homework for you. Y is equal to sine inverse of 3x minus 4x cube, and you think about this, what is the special substitution to be taken here for x. You see here, you think about the trigonometric functions, sine x, cos, sine theta, cos theta, tan theta, those functions. Of those functions, which function is comfortable to take x is equal to here to get a formula? Because our final target to make this inner function as a function of sine, so that this sine inverse and sine will eliminate each other. So is it not x is equal to x is equal to sine theta? If you take x is equal to sine theta here, then it is 3 sine theta minus 4 sine cube theta, and 3 sine theta minus 4 sine cube theta is equal to sine 3 theta, and then inverse and forward function will eliminate each other. 3 theta will be there, and 3 into theta is sine inverse x now. So 3 sine inverse x will be there. Then differentiate. 3 into sine inverse function derivative is 1 by root over 1 minus x square. So that will be the answer. You may use the direct method also by considering these whole terms as x and using the formula for the differentiation of sine inverse. But that method is not comfortable actually. You have to use the suitable method by taking x is equal to sine theta. Okay, so I think you can solve this problem and this problem. This is a very simple question. Now you see y is equal to sine inverse of this. Now you see we have the formula for 2 tan inverse x, 2 tan inverse, sorry, I have the result for this. I have the result here. You see, before that, Just a minute. Okay, so we have the formula. To tan inverse x, already discussed in the previous video, tan inverse previous screen. Tan inverse x, to tan inverse x may be is equal to sine inverse of what? Sine inverse of, it was 2x by 1 plus x square, is not it? And this is equal to cos inverse of what? Cos inverse of, it was 1 minus x square over 1 plus x square. That is, I am telling you here that if this is cos inverse, then we have the formula. This is cos inverse, then we have the formula, but it is not given in terms of cos inverse. But we have another formula in our inverse trigonometric chapter, that sine inverse x plus cos inverse x, it is equal to pi by 2 only. So from using this formula, you can convert sine inverse x in terms of cos inverse x, or cos inverse x in terms of sine inverse x. Here we have sine inverse x, but if you are to make this sine inverse in terms of cos inverse, then using this cos inverse x is equal to pi by 2 minus sine inverse x. So here y is equal to pi by 2 minus sine inverse x is now pi by 2 minus cos inverse x. So pi by 2 minus cos inverse x. Now this part can be written as 2 tan inverse x, is not it? Okay, so I am erasing this. You use that 2 tan inverse x. So pi by 2 minus 2 tan inverse x. Now just differentiate. This is the formula already I have written here. So dy dx is equal to, pi by 2 is a constant number, so it will be 0 minus 2, and tan inverse x derivative is 1 by 1 plus x square. So it is minus 2 by 1 plus x square is the result for the question. Okay, so first here I am using this formula to make sine inverse in terms of cos inverse. Then I am using this formula to get easy calculation for this. Okay, so this is homework. Y is equal to cos inverse of 2x by 1 plus x square. You see, if 2x by 1 plus x square, this 2x by 1 plus x square, then it should be sine inverse, but here it is cos inverse. So before using this formula, you are to use this formula to make this cos inverse in terms of sine inverse by writing just pi by 2 minus sine inverse 2x by 1 plus x square. Then sine inverse 2x by 1 plus x square is equal to 2 tan inverse x. Use that and finally differentiate as like this question. Okay, so I think you can solve this problem easily. Now you come to this question, and it is an important question. And before using the solution, before writing the solution of this problem, first of all you have to know one formula again here. This is the formula, sine inverse x, you may consider here plus or minus, say sine inverse x plus sine inverse y, it is equal to sine inverse of x into root over 1 minus y square. Then if this sign is taking plus, here will be plus, this sign is taking minus, then here will be minus, then plus y into root over 1 minus x square. Simple, these two sine inverse function combined by using this formula, sine inverse of x into root over 1 minus y square, and plus y into root over 1 minus x square. So I am going to use this formula here, but this formula is not directly applicable here. We have to some modification here before using this formula. So you see that modification first. So y is equal to sine inverse, this is x square into root over 1 minus, this x can be written as root x whole square, as like this. This root x is working as y. Is that clear? Root x is working as y, and this x square is working as x. Then here it is minus, so I am using minus here. Then y into this y mean root x, into root over 1 minus x square mean this one. this is x now, so this square formula. Here x square is working as x and root x is working as y. Now compare this, sine inverse x into root over 1 minus y square, then minus y into root over 1 minus x square. So now you can separate this by using this formula. It is sine inverse x minus sine inverse y, that is sine inverse x square minus sine inverse root x. So y is equal to sine inverse x square minus sine inverse root x. Now differentiate it very easily. So dy dx is equal to sine inverse function derivative is 1 by root over 1 minus this square, mean x square whole square. Then since it is not x, so considering it is it as x, therefore you are to write the differentiation of twice x by the chain rule. It is 2x, then this minus is here. Again sine inverse function derivative is 1 by root over 1 minus x is root x now, so root x square into this is considering as x, therefore derivative of root x you are to write here, it is 1 by 2 root x only. Now just simple calculation. So here it is twice x by root over 1 minus x to the power 4 into minus 1 by this 2 root x and 1 minus root x whole square is simply x, and that is the solution for the question. So let me take another question. 25. Y is equal to tan inverse of root over 1 plus x square minus root over 1 minus x square divided by root over 1 plus x square plus root over 1 minus x square. And here a to the power k plus x to the power k, a to the power k minus x to the power k, both terms are present. So we are to take here a is 1 and k is 2. You see here a is 1, k is 2, because 1 can be considered as 1 square. So you are to take x square is equal to cos 2 theta now. So let x square is equal to cos 2 theta. So find the value of theta here. First cos will go there, cos inverse x square, then theta is equal to half cos inverse x square. Now use this substitution here. My final target is what? My final target to make this inner function in terms of tan actually, so that this tan inverse remove. Okay. So y is equal to tan inverse of root over 1 plus cos 2 theta root over 1 minus cos 2 theta, replacement only. Then 1 plus cos 2 theta has the formula 2 cos square x by 2 cos square theta, and it is 2 sin square theta. If it is plus, then cos square, and if it is minus, then it is sin square, and write the half of this angle. Okay. So tan inverse of root over 2 cos square x minus root over 2 sin square x, then this one, and for this one root 2 will cancel. So we have tan inverse of cos theta, this root over and square will cancel out, cos theta minus sin theta here, cos theta plus sin theta here is equal to tan inverse of, make it 1 by dividing cos theta in the numerator and denominator. So it is 1 minus tan theta divided by 1 plus tan theta. So as done earlier, this 1 is equal to 10 pi by 4, and here you can consider 1 on here 1 into tan theta, so that 1 is equal to 10 pi by 4 again. So the inner part is now 10 a minus b format, that is 10 pi by 4 minus theta. So tan inverse of 10 pi by 4 minus theta will be there. Okay, so then this 10 inverse and 10 will eliminate each other. So it is y is equal to pi by 4 minus theta. So then use the value of theta again from the substitution you have taken. So it is y is equal to pi by 4 minus, the substitution was x square is equal to cos 2 theta. So theta is equal to half cos inverse x square is using in place of theta. Then differentiate. Now differentiation is easy. So dy dx is equal to pi by 4 is a constant number, so derivative is 0. This minus half is there. Cos inverse function derivative is negative of 1 by root over 1 minus this term square, x square whole square, into derivative of this x square by chain rule, it is 2x, and that is implies dy dx is equal to this negative make positive 2, and this 2 will cancel, so numerator is x only and denominator is root over 1 minus x to the power 4, this one x to the power 4, and that is the solution for the question. So this question is homework for you. Y is equal to tan inverse of root over 1 plus sin x divided by 1 plus sin x, 1 minus sin x. So 1 plus sin x is actually cos x by 2 plus sin x by 2 whole square, and this is cos x by 2 minus sin x by 2 whole square. Then whole square and root over will remove each other. So numerator is cos x by 2 plus sin x by 2, and here cos x by 2 minus sin x by 2. As done the previous problem, in the previous problem it is 1 minus 10x by 2, 1 plus 10x by 2 in the denominator and numerator respectively. Then use the formula 10 pi by 4 minus x by 2, or 10 pi by 4 plus x by 2 will be here. Then 10 and 10 inverse will cancelled out, so x by 2 will remain there, and then you find the derivative for the question. Very simple question actually, you can solve yourself by taking the help of previous question. So now you see one important question, y is equal to cos inverse 3 cos x minus 4 sin x by 5, and you can solve this problem by taking this total term as x. I told many times earlier that this total term can also be considered as x, and by using the formula for cos inverse x, and that in that system the calculation is heavy, and that is why we should always avoid that method. But when we have no way to differentiate or to simplify this inner function, then we have to use the direct method. But if we have some way to make this function, make this term in a simple format, then we should use that method. Okay, so now we should try about this term making in terms of cos. And you see, since this is cos inverse, so to get here cos, we take 3 is equal to cos theta and 4 is equal to sin theta, that is cos x cos theta, sin x sin theta. 3 is taken as r cos theta and 4 is taken as r sin theta, so that the format comes out as cos of something. Okay, so we are taking 3 is equal to r cos theta and 4 is equal to r sin theta. Do not take 3 is equal to you may take 3 is equal to r sin theta and 4 is equal to r cos theta. You may take, the answer will come out in that case also, but I am not taking that to get if you take this as sine and this as cos, then one negative sign will come there. In the last part we have one more extra line will be there, and that is why from the very first beginning I am avoiding that negative sign. So I am taking 3 is equal to r cos theta and 4 is equal to r sin theta to make this term as cos, because outer function is cos. But if you take this is sine and this is cos, then it will come as sine. So cos inverse of sine, but that sine can be made in terms of cos by writing sine cos pi by 2 minus theta. Okay, so in that case also the answer will come out, but here I am taking cos and for this one it is sine. So to find the value of r, squaring and adding, this squaring and adding, so it is 9 plus 16, so 3 square 4 square is equal to r square is common, cos square theta sin square theta, so r square is equal to, it is 925, r is equal to 5. And to find the value of theta also, because r and theta, these are supposed terms, so you need those values. So to get the value of theta, you divide this term by this term. Dividing, we get, you see, r sin theta divided by r cos theta is equal to 4 by 3. R and r is cancelled, it is tan theta is equal to 4 by 3, and theta will be equal to tan inverse of 4 by 3. So r is 5 and theta is equal to this. Now using these substitutions inside this given function. So y is equal to cos inverse of this 3 is r cos, this is r sin, and r is common. R is common. So cos x cos theta, sin x sin theta will be there, divided by 5 is already here. And you see here r is equal to 5. So this 5 and this r can be cancelled out. So it is cos inverse of cos a cos b minus sin a sin b, it is equal to cos of a plus b. Okay, that is x plus theta. This inverse function will eliminate each other, inverse and forward function. So we have only x plus theta now. It is x plus theta, and theta was tan inverse 4 by 3. So y is equal to x plus theta is tan inverse 4 by 3, and this is an absolute constant. So in differentiation it will be 0. Dy dx is equal to 1 only. This is 0, and this is the way to find the derivative of this types of function. Okay, so if you want to take 3 as r sin, 4 as r cos, it is okay. R will be same value 5, and this will be 10 3 by 4, that in that case. So cos inverse of here it will come as sine of x minus theta or theta minus x. That term will come here. Then sine should be converted to cos by using cos of pi by 2 minus theta. Then cos will cancel. That is a complicated one, and that is why I am taking very simple way, and you should also use this method. Do not use complicated method. Always try to find the simple format. Okay, so that is the solution. And this question is homework for you, and you can solve it by taking root 3 as r, since the outer function is cos, so it is r cos and this is r sine, r cos r sine, as like that. Or you may also write like this, root 3 by 2 cos x and half cos sine x, by dividing, separating the division, root 3 by 2 cos x, half sine x. In place of root 3 by 2, you can write cos of pi by cos of pi by 6, cos of pi by 6, and in place of 1 by 2, you can write sine of pi by 6. That is, it will be cos x cos pi by 6 plus sine x sine pi by 6, and that is cos of x minus pi by 6. And then cos and cos will cancel out. X minus pi by 6 differentiation is simply 1. Or you may also use the previous method only, that is by taking root 3 is equal to r cos and 1 is equal to r sine. In both cases you will get the same answer. So this question is homework for you. Then you take another question, y is equal to sine inverse of this one, and it is also homework. And this question you can solve by taking this x is equal to cos 2 theta, because 1 plus cos 2 theta, and here it will be 1 minus cos 2 theta. 1 plus cos 2 theta is what? 1 plus cos 2 theta is 2 cos square theta. I am just giving here, you see the numerator, outer function is sine inverse, it will remain same, sine inverse, and here it will be root over 2 cos square theta after taking x is equal to cos 2 theta, and plus it will be root over 2 sine square theta, is it, sine square theta, and whole terms divided by 2 is there, 2 is there. Then this root 2 can be taken common and cancel with this 2 to get root 2. That means in the next line you will have, this one, is it, and you will get here root over 2. Then as done in the previous question, 1 by root 2 cos pi by it is sine inverse now, so you write 1 by root 2 is sine pi by 4 into cos theta, plus this 1 by root 2 is cos pi by 4 into sine theta. Sine a cos b cos a sine b, that will give us sine pi by 4 plus x, pi by 4 plus theta, and sine inverse will cancel, so you will have only pi by 4 plus theta, and theta is equal to cos 2, x was equal to cos 2 theta, so theta will be equal to half cos inverse x. Use that one, and finally you can find the solution. And try yourself. If you are unable to solve this question, I will help you later on. But I think you can solve. You can solve. Okay, so then the next question is this one. Y is equal to sine inverse cos x, cos inverse sine x. So remove this cos with sine inverse by writing this in terms of sine and by writing this in terms of cos. Very simple. So it is pi by 2 minus cos inverse, this sine inverse, cos inverse of cos x, or pi by 2 minus sine inverse of this sine x. Or you may also write this. You may also write this. You may also write this sine inverse is already outside function, and this cos can be written as sine of pi by 2 minus x. You may use this method also. Okay, and for the second one cos inverse is already here. here it is plus sign, cos inverse is already here, and the inner function can be written in terms of cos like this, cos of pi by 2 minus x. Okay, so in that way sine inverse sine cancel, it is only pi by 2 minus x, cos inverse cos cancel, pi by 2 minus x. And here I am using actually that formula. Which formula you see? I am using this formula, sine inverse x plus, it is inverse, sine inverse x plus cos inverse x is equal to pi by 2. This formula is using here. That is, in place of sine inverse x we can write pi by 2 minus cos inverse x. Okay, or cos inverse x is equal to pi by 2 minus sine inverse x, and here x is here x is considering as cos x. Okay, so I think you can solve this problem in the other method also, like this. You may use this method. Okay, so that is the way for writing this. Okay, so now this cos inverse cancel, sine inverse cancel. It will be pi by 2 mean pi, this inverse cancel minus x, and this inverse cancel minus x. So pi minus 2x, and differentiate it, it is minus 2 only, because pi is 0 and this is minus 2 only. Okay, so the next one, y is equal to 2 by root over a square minus b square. This is constant number. Don't think about this one. Then tan inverse this, and this part is already done. We have already done this part in earlier part. So very simple, dy dx is equal to, this is remaining same, tan inverse function, it is 1 by 1 plus this whole term square into d dx of this part. This is constant, so remaining same, tan function derivative is sec square, x by 2 remaining same, then x by 2 derivative is 1 by 2. Simple calculation. And here you see 1 by a plus b. How it is get a plus b? You see root over a plus b into a minus b is here, and this root over a minus b will cancel with this root over a minus b, and here we have only root over a plus b, and here root over a plus b makes us root over a plus b root a plus b into root a plus b is equal to simply a plus b, because root a minus b and here root a minus b will get cancelled. So 1 by a plus b will be there, then this 2 and this half will cancel, and 1 by, this is 1 plus, this root will be removed, sine square by cos square, because tan means sine by cos, it is sec square remaining here, then 1 by a plus b remaining this, LCM is a plus b cos square x by 2 will go to the numerator, so this term is going to the numerator, this term will come in place of 1 here, and plus a minus b sine square is remaining there into sec square is 1 by cos square only. Then 1 by this a plus b and this a plus b is cancel, this a plus b is cancel, and this cos square and this cos square is cancel, and simply after completion this product, this a cos square and here a sine square, taking a common, cos square x by 2 plus sine square x by 2, and b common, cos square x by 2 minus sine square x by 2, already discussed in the earlier video, earlier screens. So it is 1 by, this part is 1, and this is formula for cos 2 theta. So cos 2 into x by 2 mean cos x, and that is the solution for the question. So we take the next question. Y is equal to tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. Simple modification will be there. You can solve this problem by direct differentiation by taking this term or considering this term as x, but that will be a heavy calculation, but we should simplify this one before solving the problem. Okay, and that can be done like this. Y is equal to tan inverse of, to make this part 1, a cube 1, because in the formula of tan inverse function formula or tan function formula, all formula about tan function or tan inverse function, you see that the leading term of the denominator will always be equal to 1. This term is always be equal to 1. in the formula for tan function or tan inverse function. The denominator's leading term is 1. So to make this 1, we have to divide by a cube in the numerator and in the denominator. So here a cube division, 3 is there, a square cancel, x by a is there. Because a cube division, a square is cancelled, so 1 by a will be there, so x by a is there, minus a cube division, so it is x by a whole cube, we can write, it is making 1 minus 3, and it is a cube division, so a is cancelled, a square will be there, so it can be written as x by a whole square. Now you think about this x by a. What is the comfortable substitution for x by a? Is it not equal to tan theta? Because in that case it will be 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Earlier we have also done a similar type question of this one. So we take x by a is equal to tan theta. So theta will be equal to tan inverse of x by a. Use this substitution here. So y is equal to tan inverse 3, this tan theta minus, it is tan cube theta, 1 minus 3 tan square theta, and this inner part is equal to tan 3 theta only. So tan inverse tan 3 theta is equal to 3 theta, and 3 into what is theta? Theta is tan inverse x by a, we write here, and then differentiate. So dy dx is equal to 3 into 1 by 1 plus x is x by a now, so x by a whole square into ddx of x by a is simply 1 by a, because a is constant, x derivative is 1, so 1 by a. And taking LCM here, a square is LCM, will go to the numerator, so it will be 3a square, then a square plus x square into, it is 1 by a, so this a is cancelled, 3a by a square plus x square, and that is the solution for the question. And today we finish the video here. You solve these questions and do the homeworks also, and practice these problems for better understanding. If you have any problem, ask me over phone. And so in the next class we will begin another chapter, differentiation of that is differentiation of logarithmic function and exponential function. That chapter will be discussed in the next class. So till then, thank you very much.